Dear students, welcome to DBMS lecture video sessions. In this lecture video, we are going to discuss about relational data model, relational database constraints. This is Dr. K. Praveen Kumar, Assistant Professor, Department of IT. So in this lecture video, we are going to discuss about history of relational model, terminology of different relational models, and characteristics of relations. So lecture level learning outcome for this CDT is you will be able to know the evaluation of a relational data model, and you can be explain how their characteristics are accessed, and you can examine the capability of constraints. Coming to real history of relational data model. So relational model was introduced by Ted Cord IBM research in 1970 and is based on the mathematical concept of relation, which is physically represented as a table. And Cord used terminology taken mathematics and principally set theory and predicate logic, so that we can have these concepts of set theory and predicate logic in relational model. The first commercial implementation of relational model became available in early 1980s by IBM is DBMS and SQL DS systems. Current popular RDMS SQL Server and Microsoft Access DB2 and Informix are the popular RDBMS. Standard for commercial RDBMS is SQL, that is structured query language. Right. So relational model consists of three major components. What are those? Set of relations and set of domains that defines the way data can be represented. That is, you can say it as data structure. And integrity rules that defines the procedure to protect the data, that is data integrity. The operations that can be performed on the data, that is data manipulations. What is relational model? Relational model represents the database as a collection of relations, and the relation is a table of values. Even every row in the table represents a collection of related data values, and these rows in a table denotes real world entity or a relationship. The table name and column names are helpful to interpret the meaning of value in each row. So the data are represented as a set of relations. So we have already created different tables and we have inserted values into the table in lab session. In the real relational model, data are stored as table. The physical story of the data is independent of the way the data is logically organized. Relational model concepts in DBMS. So the first one we need to remember is attribute. So attribute, each column in a table is called as attribute. Attributes are the properties in which defines the relation. For example, student roll number is an attribute. Name is an attribute for the student table. Tables in a relational model, relations are stable in the form of table format. It is stored along with its entities. Table has two properties, rows and columns. Rows represents the records and column represents the attributes. Tuples. So tuple, it is nothing but a single row of a table which contains a single record. Relational model concepts in that. The next one is relational schema. So a relation schema represents the name of the relation with its attributes. And a degree. Next one is degree. The total number of attributes which in the relation is called the degree of the relation. The number of attributes. If there is 5 columns, the degree of the relation is 5. So cardinality. Cardinality is the total number of rows present in the table. It's called as cardinality. And the column represents the set of values for a specific attribute. So relational model concepts in the DBMS is relation instance. Relation instance is a finite set of tuples in the RDBMS system, and relation instances never have duplicate tuples. These values are never be duplicate. Relation key, every row has one, two, or multiple attributes, which is called relation key. And attribute domain, every attribute has some predefined value and scope, which is known as attribute domain. The domain contains a set of atomic values that an attribute can take. Relation schema. So relation schema are donated by R of A1, A2, A3, and so on. These A1, A2, A3 are attributes. Capital R is a relation. So you can represent R of A1 to AN. And each attribute AI is the name of a role played by some domain D in the relation schema R. And capital D is called the domain of AI and is denoted by DOM, domain of AI. The degree, that is the number of number of columns of a relation is the number of attributes n and its relation schema. See, this is the example. Student is a relation and its attributes A1, A2, A3, and so on. AAGGPA. So using the data type of each attribute, the definition is sometimes written. It is like this. So student is a relation name. Student is a relation name. Name is the attribute, and string is its data type. SSN is attribute, and string is its data type, and so on. Relation state. A relation state, small r of capital R, small r of capital R, small r of capital R is a mathematical relation of degree n on the domains, domain of A1, domain of A2, domain of A3, and so on, domain of AN, which is a subset of the Cartesian product. It is denoted by this cross mark of the domain that defines like this. So a relation R is a state of relations subset to domain of A1, Cartesian product, domain of A2, and so on, domain of AN. So the Cartesian product specifies all possible combinations of values from the underlying domains. So the total number of values or cardinality in domain D is represented by a pipe symbol of D, and it is assuming that all domains are finite. So the total number of tuples in the Cartesian product will be like this. Domain of A1, domain of A2, and so on, domain of AN, all the Cartesian products. Relation state is a subset of Cartesian product of the domain of its attribute. Each domain contains a set of all possible values that attribute can take. So this is the example. Attribute customer name is defined over the domain of character string of maximum length 25. So domain of customer name is varchar 25. So the role these strings can play the customer relation is that the same name of a customer. So characteristics of relations, ordering of tuple within a relation. A relation is a set of tuples, and the tuple in a relation need not to have any particular order. So this is need not to have any particular order. So ordering a value within the tuple, and n tuple is an ordered list of n values. So ordering of values in a tuple is important. So with an alternative definition of relation, ordering of values in a tuple is unnecessary. So ordering of values within a tuple is, so a tuple is a set of all the row values, then ordering of attribute is not important. So values and null in a tuple. So each value in a tuple is an atomic values, single values. And the nulls are used when the values are unknown, are not applicable, are not needed. Then there you can enter the null values. So interpretation of relations. The relation scheme can be represented as a declaration or assertion. Each tuple can be interpreted as a factor. So the notations of a relational model. So a relation R of degree n is denoted by R of A1 to AN, A1 to AN. So the uppercase letters Q, R, S denotes the relation names, and the lowercase letters Q, R, S, small Q, R, S denotes it denotes the relation states. So letter TUV denotes tuples. TUV denotes the number of entire rows. So in general, name of a relation schema such as student also indicate the current set of tuples in that relation. The current relation state, whereas student name SSN refers the only relation schema. Relation model notations, you can say like this. And n tuple T in a relation R of small r, this is states and this is relation, is denoted by T is equals to Vi, where Vi is the value corresponding to the attribute A. T is a tuple. Following notations refers the component of values of tuples. Both T of AI and T dot AI refers to the value of Vi in T for attribute A. Both T of AU, AW, AZ and T dot AU, AW, AZ, where AU, AW, AZ is the list of attributes from the relation R. So refers to the subtuple of values from T corresponding to the attributes specified in the list. Relational model notations. This is the one of the example tuple T from student relation R. This is the example. So relation model constraints. So relation model can be divided into three main categories. Constraints that inherent to the data model. We call this inherent data model constraints, or implicit constraints. Constraint that can be directly expressed in the scheme of data model, typically by specifying them in the DDL. We call these schema-based constraints or explicit constraints. Schema-based constraints are explicit constraints, constraints that cannot be directly expressed in the schema of the data model, and hence it must be expressed and enforced by the application program. We call this application-based or semantic constraint or business rules. Schema constraints, domain constraints, key constraints, constraints and nulls, entity or integrity constraints, referential integrity constraints, and all these constraints we have already done in the laboratory session. That nothing but you are posing some rules onto your particular attributes. So this is domain constraint specifies that each tuple, within each tuple, and value of that each attribute must be unique, right? This specifies the data type, which includes the standard data type integer, real number, characters, Boolean values, etc. Create some domain, you can say table, table name, customer name, check value should not be null. So this example demonstrates creating domain such that customer name is not null, it is mandatory. So this is all about in this video lecture. In the next video lecture, we will discuss with some of the next topic. Thank you.